Hi, so I wanted to go over a few generalizations of the theorems that we are starting to understand in class. And so I wanted to go over, um, first of all, I wanted to review the ideas behind the proportions that we get from similar triangles. So I'll just create a few similar triangles here, right? And I'll make this side 4, this side 3, and this side 2, right? And I'll make this side 8, 6, and 4, right? Obviously, you know that the scale factor is 2. But what if we didn't obviously see that the scale factor was 2, right? How would we find the scale factor? One way we could find the scale factor is comparing the sides, right? If we see the two largest sides, if we do one over the other, we get the scale factor, right? But what we could also do is we could look at another pair of sides, and we know that that's also the scale factor. And make sure you're doing uh, the big side to the smaller side, or right, the big triangle to the smaller side to the smaller triangle, or vice versa, right? And so, what if I replace this, right? What if I replace this with x and this with 4 again, right? How would I find x, right? It's simple, right? First, what we can do is we can look at the scale factor. Our scale factor, right? We can say that our scale factor is, we can look at our 4, and we can do 4 over 2, and that is our scale factor. But what is also our scale factor is this side and this side, right? And so, we can also know that our scale factor is x over 4. Now we have our equation, right? 4 over 2. 4 over 2 becomes 2, right? Is equal to x over 4. Multiply both sides of the equations by 4. And then we get x is equal to 8, right? And that's the whole idea of this proportion. Another way that we could set up our proportion is we could look at the inner ratios, or what I like to call them, or within ratios, right? Right. And so if we look at in one triangle, right? If we look at the ratio between our hypotenuse, right? Our hypotenuse to our shortest side, our 2, since when we dilate it, the within ratios do not change, right? We know that the ratio, we know that it will be equal to the ratio of our longest side over here and our shortest side over here, right? And so we can conclude, right, that of course this would also become 2. 2 is equal to x over 4, and then x is equal to 8, right? Of course, these numbers are kind of bad because both our scale factor and the within ratio I was using um, was 2. But let's say if we looked at not 2 and 4, but let's look at 4 and 3, right? 4 and 3, and x and 6, right? The within ratio between 4 and 3 will be equal to the within ratio between x and 6, right? Change that to fraction form, and then solve, right? Multiply both equations by 6, so that we get x is equal to, this becomes a 2, 8, right? And that's our answer again, using within ratios. So that's how we get our ratios that we've seen in classes, in class, right? So if you have this kind of problems, don't, and I'll say this again, don't solve for this middle line over here, okay? For Takeuchi students, don't. Just use what you know of similar triangles, right? First of all, let's prove, for example, that this triangle right over here is similar to, now I'm not gonna say this triangle as that doesn't help us. Try look at this entire triangle, right? Let's look at this angle first, right? We know that that angle is, for this triangle, it's across from this side, right? But we know that this angle is also across from this side, right? And we know that we also have 90-degree angles, so we can already conclude by AAA that these triangles are similar. So let's name the triangles and their similarity, right? Let's go let's go from angle 1, I, to the right angle, which is A in this case, to the double angle, which is Z, is similar, right? And these are both triangles, are similar to, right? Is similar to, right? I again, because that's our small angle, to our right angle, which is C in this case, and then to our D, or double angle, so D, right? And so let's redraw these triangles, right? And this might help to better think about these triangles, right? This is 8. And then let's draw the entire triangle, right? And then of course we could label them. This was I, A, and then Z. And then I, Z, and D, right? We're gonna rotate this triangle around. We know that the side across from Z, this right angle, will be this entire side, which is 18. The side across from I is this side, which we don't know. And then the side across from D is X, right? And so, if we look at our triangles now, we can set up our proportion, right? For this, I'll just use the scale factor, right? X, we can use, yeah, you can either do X over 18, which is the scale factor between, uh, between this to this, well, sorry, this to this, right? And so I'm just going to use that is equal to this side to this side, right? So 8 over x. Now we can cross multiply. X squared is equal to 8 times 18, right? Multiply that out and you'll get your answer. No solving for this middle side. It just takes thinking and good basic understandings, good fundamentals, and not just a formula into another formula, right? Now, here's something that I will prove. Let's use this as an example, okay? So my claim, okay, is that if you look at this triangle, I can already say that x times y is equal to, x times y is equal to 12 times 8. 12 times 8. And that would be a kind of like a formula that you know, but it's just a generalization of what we know, right? Normally, we would create these lines, and we know that this angle is equal to this angle. Similarly, uh, and then we can look at, uh, we can see that this would be like a reflection line, and you'll find that this angle is equal to this angle, right? And this angle is equal to this angle, right? And that's what we did for our 10,000 other triangles, especially when we did this in class, right? But now we can use our ratio, right? We can take the side across from the double angle, right? Side across from a double angle, y over 12 is equal to the side across from our whatever this angle is. So 8 over x, right? And if we multiply both sides by 12x, right? By 12x, on the left side, this will cancel with this, and on the right side, the x's will cancel, right? And so x times y will be equal to 12 times 18. Now, this is just a shortcut, right? You know that since these are chords, this uh, formula right here will always works. It will always work. It's called the intersecting chord theorem, right? And those are big words, so I'm just going to delete it, but just remember that this times this on the same line is equal to this times that on the other same line, right? It might get hairy when it says that this is x and they scribble this out and they say like this is x minus 8, but it's the same thing, right? You just plug it into your formula. X times x minus 8 is equal to 12 times 8, and then you solve that, right? Okay, right. Here's another problem that actually wait no. Yeah, yeah, okay. This is a problem where we can use this theorem, right? If you just wanted to find x, right? We can say that this side and this side, if we multiply them together, 5x is equal to this side multiplied by this side, which is equal to 15 times 4. Divide by 5 on both sides, x is equal to, right, cancel these, and then 3 times 4 is 12. And boom, you already have your answer. Now, these problems on the third page, yeah, they seem quite hard, but once you realize that there's a generalization of these kinds of things, right? First, I'll do it in the general case, right? First of all, we have this angle, right? And we see from these two triangles that it's a shared angle, okay? Now, since both this and this angle is opening up to uh, this side right here, we know that they're also equal, right? And so now we can conclude that uh, they are similar from AAA, right? And so now we can just do our proportions, right? So let's first look at this side. So OB, okay? OB. And then let's look at the inner ratios now. And let's look at the side across from the double angle now. OB, and then let's call that BR, okay? Is equal to, we have to look at the side across from this first angle. So that side will be BE in this case, BE. And then we have to look at the side across from the double angle, which would be BN, okay? Now if we multiply both sides by BN times BR to get rid of the denominators, okay, then we can find our generalization. So we get that BN times OB is equal to BE times BR, okay? Now, right now, this might just look like a lot of letters, but let's actually look at it in in this problem. Okay. Okay. Well, first of all, we need to know what we're looking at. So BN, right, is this entire length, while OB is just this small length. And then BE is this small length, and BR is this entire length, right? And so we're looking at this times this entire thing is equal to this small thing times this entire thing. And they're both on the same side, right? And so here we can find the generalization, right? If we call, for example, if we call this x, y, and then a and b, we get that x, right, the small side, times x plus y, this entire side, is equal to a times a plus b, right? This small side and this very long side. So now we just need to find, we can try it on this problem, right? If py, I'm just gonna do b, right? If py was 2, right, find ty. Now we can use what we just learned, right? This short side times this entire side. Be careful with that because it gives that only this side is 4 and only this side is 4 and only this side is 5, right? And so this entire side will be 9. So it will be 4 times 9 is equal to our other short side, which is 2, times the entire thing. So I'm just going to say 2, right? Py, 2 plus yt, right? And that's what we're trying to find. So now we can just solve, right? No similar triangles needed. So we can divide by 2, right? This would cancel out. 18 is equal to 2 plus yt, and then we get yt is equal to 16. And boom, you already have your answer. That's all you really need to know. Hey guys, so I know the formulas that I came up with had some pretty weird letters in it and some weird notation, so here's just a recap of what I said for the chords theorems. I just went ahead and typed it up, and these might be a little bit easier for you guys to visualize and to remember. Okay, bye.